Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this particular video, we're going to take a look at uniform motion and how to address and to solve uniform motion equations. When you're dealing with uniform motion inside algebra, the key term that you have to keep in mind is kind of obvious, is uniform. This means that at whatever speed or whatever motion the particular concepts have inside the actual word problem, they're always moving at the same speed throughout the actual problem. And the way that we calculate uniform motion, or distance, is commonly considered by d, which is distance, equals r, which is rate, times t, which is time. So distance, this is distance here, this is rate, and this is time. These are the three components that are used to calculate uniform motion. And so now what we're going to do next is we're going to take a look at an actual word problem where we are required to use uniform motion. So here's our problem. Tom and Dan both ride motorbikes from school to the beach. Tom's speed is 14 miles per hour faster than Dan's. Tom takes 45 minutes to get to the beach, while Dan takes 1.5 hours to get to the beach. Find the speed of both. Now, for beginners and people who are not quite as comfortable with this, often one of the first things you want to do is you want to draw some sort of a picture to help you visualize what's going on. So over here we got Tom, we got Dan, and they're both leaving from the school. So they start in the same place and they end in the same place. And they both travel the same distance here. And the next place that they get to is the beach. Now, here's the thing. Tom is traveling 14 miles per hour faster. And he spends a total of 45 minutes to get there. Dan, on the other hand, takes 1.5 hours. Now, that's our picture. Another thing that you might want to do, and this is probably very important, especially even for people who are much more comfortable with math, is you want to set up a table in which you put all the information that you have to try to set up the equation that you're going to use. So here's what we got. We got Tom again. We got Dan again. All right, that's one piece of information. That's what we have. And we have some other information that we need to also include. So we know that they have a rate. That's going to be our R times our T, which is going to be time, which is going to equal our distance. We already drew this. So what was the rate? Well, Tom's rate was R, which is plus 14. Because remember, he was going faster than Dan. And so Dan is just going to be R. He's kind of the base variable, if you will, the constant, if you will. Now, what was their time? Well, again, we know this. We know that Dan, he took 45 minutes, but we're going to convert that to hours so that we have the same units for Tom and Dan. So that's going to be 0.75 hours for Tom, and of course for Dan it's going to be 1.5 hours. Again, this information is taken directly from the word problem. 45 minutes is 0.75 hours. 1.5 hours is 1.5 hours. And now, so what was their distance going to be? Well, what you do to get that answer is you take this information here and you combine it together through multiplication. Why are we doing multiplication? Well, if you look right here, we have a multiplication sign between R and T. So to get this answer, we have 0.75 multiplied by R plus 14. And then we have 1.5 R. Again, that's all through multiplication right there. Now, we have all the information that we need to solve the equation. But what we have to remember is that when we're dealing with Tom and Dan, Tom is going to equal Dan. And so on the next screen, I will show you what that looks like real quick. So here's what we got. This is what we got. We got Tom's information, which is 0.75 times R plus 14 equals 1.5 R. Again, Over here is Tom, over here is Dan. They equal each other because at the end of the day, they traveled the same distance. Remember, both left the school and both went to the beach. So they traveled the same distance. Now, what we have to do now is we have to distribute our information with the parentheses on the one side, combine the like terms, and then solve for the actual variable, which is r. So the first thing we're going to do is, I'm sure you can tell, hopefully, if you're a little more comfortable, is multiply this and multiply this. So we get 0.75 r. 0.75 times 14 is going to be 10.5, and we haven't done anything to the 1.5 r yet. Now, the next thing we have to do, again, you should already be somewhat familiar with this, is we need to subtract 0.75 r from both sides. And so then we're left with 10.5 equals 0.75 r. That's what we have. So we were able to remove this, and now we have what's left over here. Now the last piece of information that we need to do, and we're just about done here, is we're getting close. We need to divide both sides by 0.75. Again, if you're familiar with how to solve an equation, this should be familiar for you. And so after you do that, you should end up with the answer of 14 equals r. In other words, we know that Dan was traveling 14 miles per hour because r equals 14. Now the question we have now is that we take that same information r and we add it to 14 because this was the speed that Tom was traveling. So if you do r plus 14 is 14 plus 14, which is not that hard, which equals 28. All right, so that was the speed. Tom was traveling 28 because he was traveling 14 miles per hour faster than Dan, and Dan was traveling 14 miles per hour. And again, if you put that information in there, you should get the answer. So again, 14 times 1.5 r is going to get 10.5. 28 times 0.75 is also something else to consider. So in this particular video, what we looked at here was we looked at how to calculate the answer for a uniform motion equation. There are lots of complicated steps for this. Excuse me. Whoops. You begin by understanding that the equation is d equals r times t. Then you set up, of course, your little table where you put in your information, and then you set up another table where you are putting in the different information that you need to figure out the answer. Of course, after that, it's just a basic equation problem where you try to isolate the variable through the various steps that you need, and then you're able to finally come up with your answer. So, my name is Darren Thomas. I'm the Director of Educational Research Techniques. I want to thank you for watching, and we'll hope to see you in the next video. Take care.